Everyone, the math tutor here. Today we are going to talk about sequences. Now, in sequences or under sequences, the sequences can be applied in different subjects, but mainly they are applied in mathematics. Alright, so we are going to look at sequences, but under sequences we have two types that I'm going to teach you today. Alright, so we are going to start by looking at linear sequences. Alright, there are two possible questions that can be asked about linear sequences. The first possible question could be, write the next term. What is the next term in this sequence? Then the other one is to find the nth term. So I'm going to focus this discussion on how to find the nth term. Alright, I hope you're ready. Get whatever you need to get. Pay attention. Watch over and over again until you understand, and also subscribe, like, share with your friends, and I hope at the end of this session you'll be able to solve all sequence problems. Alright, so first thing you need to do in order to find the nth term, by the way, nth term means position, any position. It could be 100th position, it could be 1,000,000th position, it could be the 5th position, so any position. So they are asking you to get a formula that you can use to get any term in any position. Now in sequences, these numbers here are called terms. So 5 is the first term, alright, 9 is the second term, 13 is the third term, 17 is the fourth term. Alright, so the first thing you need to do here is to find what we call the rule, the term to term rule. So what do they do to 5 to get 9? What do they do to 9 to get 13? What do they do to 13 to get 17? So you realize that they are adding 4. Okay, so this is where the name comes from, linear sequence, because they are adding 4 to every term to get to the next one. Okay, so this here, the 4 is called the term to term rule. Now if I want to get the nth term, first of all you look at the rule, write it down, and put an n besides it. So 4 times the n. Alright, 4 times the n is always the first step. Okay, and then we add on open parenthesis or bracket, always get the first term minus the rule. Okay, so with that you conclude that the nth term will be 4n plus 1. Alright, you can even test and see if you've got it. I'll write here the small word check. So remember, n is position. Let's check if in the second position we shall get 9. So I'll have to say 4 times 2 plus 1. You realize that you're getting 9. So the nth term is this, and this is how you check it. Okay, let's try to apply what I've explained in number 2. So the rule is plus 3. You see that we are adding plus 3. Okay, so now we get the rule, put the n plus first term minus the rule. Okay, this is the working. So here we're generally getting 3n plus 7. Okay, testing it, you realize that for example, you can test the third rule, 16. See if you can get 16. So 3 times, I want to get 16. So 3 times 3 is 9, and then plus 7. you realize that you get 16. So this here is how we solve linear sequences. Alright, I hope you got it. I hope you understood that. So let's talk about another type of sequences that is very common. It's called quadratic sequences. Quadratic sequences. Okay, I hope I got the spelling correct. Okay, we shall go directly to an example. Let's get an example. 4, 7, 12, 19, 28. Okay, you can stop there. Now, here, like in the linear sequences, step 1 is to get the rule. So we shall see why they are called quadratic. So here is plus 3, this is plus 5, this is plus 7, and this is plus 9. Okay, now at this stage you realize that, oh my god, they are not uniform. So you continue, okay, continue until you get a uniform term to term rule. Okay, so this is plus 2, this is plus 2, and this is plus 2. Now, when you get a uniform term to term rule, you stop. Okay, so you write the rule, multiply by n, but because you moved through 2 steps, this is step 1 and this is step 2, you power this to 2. Okay, you power this to 2, so it will be n power 2, and still because of the 2 steps you divide this by 2. Do you get that? Because of the 2 steps you power to 2, and because of the 2 steps you went through to reach the uniform term to term rule, you divide by 2. So if this cancels with that, here we shall get n power 2. Okay, I hope that is understood. Then the next step is we draw a simple table. Okay, we shall write in that table position. We write here the sequence. I'll explain what this is, and then we write what we got in step 1. In this we write the n squared. Okay, so we shall now start. Okay, this is a simple table just like this. Right, so positions are first, second, third, fourth, fifth. How many positions we have? 6. Okay, these are positions. Okay, now we are going to write the sequence as it was given: 4, 7, 12, 19, 28. Okay, you can leave out the other one. Now n squared is position squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. Okay, now at that stage you are going to get the difference. Okay, this is what you always do whenever you are solving a quadratic sequence. Quadratic sequence, when you are finding the nth term of the quadratic sequence. So we are finding the nth term. Okay, this lesson is only to find the nth term. Finding the next term is easy, you can figure that out. So finding the difference means that you're going to only find the difference between the sequence and the n squared. So 4 minus 1 is 3, 7 minus 4 is 3, 12 minus 9 is 3, 19 minus 16 is 3, 28 minus 25 is 3. Alright, now our last step is to find the nth term of this difference. Okay, just like we did in linear sequences. So here you realize that you added 0 to get to the next term. You just add 0 like that. So we do what we did with linear sequence, write the term to term rule, n plus bracket the first term minus the rule. So 0 times any number is 0. Okay, so that means here we shall end up with just 3. Okay, so we say therefore the nth term is n squared plus 3. This here is the answer to that. Let's test it. I want to get the fourth term, 19. So let's see. So if I want to get the fourth term, n is position, so I'll say 4 squared plus 3. So 16 plus 3 is 19. So this here is the correct answer of that. So these are the steps you follow when you're getting a quadratic sequence, nth term of a quadratic sequence, and these here are the steps you follow when you're getting the nth term of a linear sequence. Okay, let's try out another example, quick one for the quadratic sequence number 2. Okay, we can say 3, 9, 19, 33, 51. Let's test it and see. So here is plus 6, okay, is 9. So let's find out what if you want to find out the next one, you just get 19 minus 9. So they added 10, so we add 10 there, and then 33 minus 19, they added 14 here. Okay, hope you're following. And then 51 minus 33, they added 18. Okay, so like I said, you have to continue to the next step until you reach the uniform term to term rule. So here they added 4, they added 4, and they added 4. Oh, this is the uniform. So you stop there, and then we said get the uniform rule, write the n because there are 2 steps, step 1 and step 2, square it, divide by 2 because of the 2 steps. So when you simplify this, we get 2n squared. Okay, continuing, we draw our table, position, sequence, and then 2n squared. So position is 1, 2, 3, 4, 5. The sequence was 3, 9, 19, 33, 51. Okay, so 2n squared is the n is the position. So 1 squared is 1 times 2, 2. 2 squared is 4 times 2, 8. 3 squared is 9. 9 times 2, 18. 4 squared is 16. 16 times 2, 32. 5 squared is 25 times 2, 50. Okay, so you follow the rules, that is 2n. Okay, now we shall get the difference, just like we did in the first example. So the difference is only, remember the difference is only between the sequence and the 2n squared, the answer you got at this stage. Alright, so 3 minus 2, 1, 9 minus 8, 1, 19 minus 18, 1, 33 minus 32, 1, and here 1. So let's get the nth term for the last one, for the difference. So it is plus 0, just like the first one. It is not a must that it is always plus 0. Okay, you need to work it out just like we did in the very first part. So now this will be 0n plus 1 minus 0, so which we get, from which we get 1. So therefore our final answer will be 2n squared plus 1, because this is plus 1. Sometimes you can get a negative, just put it there. Okay, so this will be the answer. We can test it. This is testing it. So I want to get the fourth term, 33. So let's see. 2 times 4 squared plus 1. So you realize that we get 2 times 16 plus 1, which is 33. Okay, so I hope the quadratic sequences are going to be very easy for you from now on. Please subscribe, like, share, and feel free to comment. Try out other examples. You can find out any examples online or from your past papers and try them out. See you in my next video. I hope this was good. We first looked at linear sequences and we went through the steps you take to find the nth term. You can have a look at them. And then we proceeded to quadratic sequences, which I've given you the general steps you take. You can apply them to any quadratic sequence. And that is the end of this session. See you in my next session. Subscribe, like, share, and also make sure you take some notes. It is always lonely at the top. See you. Bye bye.